Math 7A, Exam 1, question number 11. Simplify the expression, parenthesis, negative 8 over 27, that's our base, raised to the negative 4/3 power. Okay, so what I did is I said, okay, I'm going to decompose this because I know that 8 and 27 are pretty sweet numbers because they're perfect cubes. And I can decompose the exponent negative 4/3 as negative 1/3 times 4. That's the way we write it using the rules of exponents. So raising a base, this is our base in the parenthesis, to the negative 1/3 to the 4th means that it's the same as multiplying the exponents together, which would give us the original exponent. I'm just trying to verify that this is a legal decomposition of the exponent. Okay, so now that I've done that, I don't like the negative sign right here. I want to get rid of that negative sign, and I do that by flipping the base upside down. That makes the exponent turn positive. And now I'm going to apply the exponent to the top and to the bottom. And the fourth power hangs around the whole time like a nasty little hitchhiker, right? It comes along for the ride. Okay, 1/3 power is the same as the cube root on the top and the bottom. Cube root of 27 is 3 because 3 to the 3rd power is 27. Cube root of negative 8 is negative 2 because negative 2 to the 3rd power is negative 8. So we raise the 4th power on the top and bottom. We get our final answer, 81 over 16. That was a cool problem. Simplify the expression. This is number 12. Express the answer so that only positive exponents occur. Of course, we always have to do that to get our simplified answer. Assume that all variables are positive. That means if you take an even index root, don't worry about the absolute value bars. Okay, here we are, number 12. X to the 4/7 times x to the 5/4 over x to the negative 4/3. Every one of these terms, they're factors because they're multiplying on the top. They are x, they're the same. So we're going to be able to smash these all together. First on the top, use the rule of multiplication for exponents. X to the 4/7 times x to the 5/4 is equal to x to the 4/7 plus 5/4. And don't forget to bring along the bottom. Okay, so now we're going to add the exponents on the top, but we need a common denominator, which will be 28. So we rewrite each of these exponents that are being added with a common denominator 28, and then we add them across the top. We get the 51/28 power of x. Now let's combine it with the x base on the bottom. That's x raised to the top base minus the bottom base. Okay, so we are subtracting the bottom base exponent, exponent, but it's a double negative here, so that makes it a positive. Now we need another common denominator. It's going to be 84. Rewrite each of these fractions with a common denominator 84. We get 153 over 84 plus 112 over 84. Add across the top over 84. X to the 265 over 84. Now that's a positive exponent, and we don't need to break that apart any further. Just leave it just like that. Number 13, scroll down. Number 13 is write the standard form of the equation of the circle with radius r and center hk. That's the ordered pair xy equals hk. So they give us for number 13, radius r is the square root of 13, and hk, the ordered pair for the center, is 9, 4. Now here's what we have to have memorized. The standard equation of a circle, x minus h squared plus y minus k squared equals r squared. Now plug in the values for h, for k, for r, simplify, and here's your answer. Parenthesis x minus 9 squared plus parenthesis y minus 4 squared equals 13. Number 14, determine whether the equation defines y as a function of x and explain why. Very important to explain why. Y squared plus x equals 2. First thing we do, step 1, is we're going to isolate y. In the process of doing that, we move the x over, and then we need to get rid of the square. So we have to introduce a even index root, which means we have to use the plus or minus. Y equals plus or minus a big square root of the other side, negative x plus 2. Now you have to ask the question, does this expression show us that x's are faithful? No, it's the actual plus or minus that causes us the problem. We can plug a value in for x and get two y partners, one with a plus and one with a minus. So that's my explanation about why the answer will be not a function. So I carefully answer it and I carefully explain why. Let's move on. Let's see, we just finished question number 14. We will continue on this video with question number 15. Determine algebraically whether the function is even, odd, or neither, and explain why. Well, here's a reminder. You evaluate f at negative x. If it simplifies to negative f of x, your answer is odd. You evaluate f at negative x. If it simplifies to f of x, your answer is even. The function is f of x equals negative x cubed over 8x squared minus 6. Let's go ahead and evaluate this f at negative x very carefully. Use parentheses to replace all the x's. Here's our minus sign that came from the function, parenthesis negative x, close parenthesis cubed over 8 parenthesis negative x, close parenthesis squared, minus 6. Now, on the top, if you cube a negative base, it's still going to be negative. So we have double negative x cubed. And then on the bottom, when you square a negative base, it will become positive. So this becomes 8x squared minus 6. Now, I'm going to go ahead carefully and pull one of these negative signs out in the front. And the reason I'm doing that, instead of making the whole thing a positive, is to demonstrate very clearly that what I have is negative bracket, and what's in the bracket is f of x, the original f of x. So my final simplified result is negative f of x. So f of negative x equaled negative f of x, and that implies that our function is odd. And that comes with the demonstration, the explanation of why that answer is true. Number 16, solve the equation absolute value of x squared minus 6x is equal to 0. So we're going to use this result. The absolute value equaling a number k means that the stuff inside x is either equal to k, or, union symbol, the stuff inside x is equal to negative k. Okay, so we use that rule to get rid of the absolute value symbol. For in this problem, we have the absolute value of x squared minus 6x equals 0. That means the stuff inside without the absolute value bar equals positive 0. That's a number on this side. Union together with the stuff inside equal to negative 0. Well, the deal here is positive 0 and negative 0 are the same number, so we only need to work with one of them. I'm going to move everything to one side, the other side 0, because this is a second degree equation. Factor the non-zero side, set each of your factors equal to 0 and solve, and you get two answers, x equals 0, x equals 6. Question number 17, solve the equation by factoring. Okay, we have a rational equation, right? Fractions are involved with variables in the bottom. X minus 4 over x equals 15 over x plus 4. Now, you could multiply both sides by the LCD, x parenthesis x plus 4, but that's the same thing as if you did a cross multiplication equals a cross multiplication. So whatever you want to call it, we get the same result. X minus 4 times x plus 4 equals 15x. Go ahead and get rid of these parentheses by using the formula a plus b times a minus b equals a squared minus b squared. And then bring down the equal sign to 15x. Oh, a second degree equation. Get everything on one side, the other side 0. Factor the non-zero side. Set each of your factors equal to 0 with a union symbol. And then solve each of your little equations. Your answers are x equals 16, x equals negative 1. And finally, number 18, solve the inequality, graph and express your answer using interval notation. First, we have to isolate the absolute value. This is an inequality. Matter of fact, this one's a little complicated. I'll finish this one on the next video. I want to spend more time on it.